Hey everybody, it's Sean. I'm coming to you here today from Virginia. Don't have my tripod to set up the phone on, so hopefully this is going to do. But today, here in this video, we're going to be talking about Arduino and a couple different projects you can do with it that are pretty cool or interesting. For those of you that don't know, Arduino is a very cheap, kind of limited PLC, which is a programmable logic controller, and basically all that means is it's a little tiny board that you can code into with your computer and tell it what to do. You can hook up buttons, switches, lights, motors, tons of other stuff. And today we have 6 projects that I've done in the past that we're going to talk about. And let's get started. So we're going to kick off these 6 projects with an Arduino temperature display. As you can see, we have a little breadboard, and there is in fact a little tiny temperature sensor. That's the little black dot that you see towards the bottom of the breadboard. We have that hooked up to the Arduino. The Arduino is basically just taking in that signal from that sensor and converting it into something we can read, which is Fahrenheit or degrees Celsius. And we are displaying that on the LCD shield. So that's a pretty simple one to set up, and lots of uses. You can create your own little thermometer if you really want to. Put it around your house, make sure that your heater AC is working. Next up, we have an Arduino sump pump alarm. I built this because my parents' basement flooded and they had no idea. I mean, you don't know your sump pump's broken until it floods. So they didn't have a backup sump pump, and just in case it failed again, I wanted to make them something. So what you see here in the beginning of the video is a little water sensor, and basically when water gets on that, it conducts electricity and sends a signal back to the Arduino. I then have the Arduino convert that signal into just a voltage, and we're going to apply that voltage to a little buzzer. So if water ever gets too high up from that sump pump well, it will touch the water sensor, and then the water sensor will set off an alarm, hopefully letting my parents know that, hey, your basement's about to flood, so go check it out. Alright, the third video is actually a pretty quick one, so I might have to repeat it here. All we have is a joystick running through an Arduino and into a motor controller to control a motor. It seems pretty simple, considering that the joystick is just a potentiometer, and we talked a little bit about that in the mini bike build, but basically what the potentiometer is doing is measuring the angle that we're moving the joystick and feeding that information to the Arduino. The important thing here, though, is that we're using a USB shield because this is a USB joystick for a computer. The USB shield just stacks on top of the Arduino and gives it a USB port that you can plug into, and then you can figure out what the signals are that are coming from that USB and convert it into something that the motor controller will want to see, like a 0 to 5 volt signal or something like that. So this is going to be useful if you want to do some sort of tank drive with a joystick, if you want to be sitting in there, pretend like you're a fighter pilot or something. You can also map all the buttons and the triggers and any other levers that are on that joystick into something that the Arduino can read, and then output the signal to something else to, control motors or flip switches or move servos or something. Alright, this one is a dog laser pointer. Basically what's going on here is there's 3 potentiometers, those little knobs there. 2 of them control the swing of the laser. So one of them will do like left-right movement and the other will do up-down movement. And the third knob actually will then control how frequent the laser moves. So you can see I crank it up and it starts going all crazy, and if you turn it the other way, it slows down and leaves the laser pointer on one spot for a longer period of time. It's actually a pretty simple setup. You're just measuring a few different potentiometers, and you're using those values to set an angle or set a position for those servos. Those are the 2 little blue boxes that you see with the lasers on them. And that's about it. We tested it out with the dog, and he likes it a lot, actually. We had this on a pretty slow setting. He couldn't keep up with it if we sent it too fast, and then once he figured out that we were pointing with the actual laser, he just stopped playing with it altogether. Alright, we are nearing the end here, and this one is one of my favorites. This was actually a school project. We had to code a robot arm with Arduino, and make it run through a program. So what I had this robot arm do is take a bunch of wooden blocks and stack them into a pyramid and then knock them over because, you know, I don't know, robots are evil or something. But I have it sped up here because otherwise it would take quite a bit of time. This was one of my first Arduino projects ever, so it was pretty slow. I didn't have the efficiency down yet, and I didn't really know, you know, all the ins and outs and things that I could do with Arduino to make it run smoother. So it looks a little jerky, and in reality it was, just because of the way I coded it, but it still worked, and it's still pretty cool. If you check this out and you think of those big robot arms that build cars or you know, other sorts of manufacturing things, it's a pretty similar concept. You're coding a robot arm to do a repetitive action, and it can do that all day long, won't get tired, doesn't need a break, and that's why a lot of manufacturing is going towards robots. Alright, this last one is my personal favorite. It is also a fairly simple one, but the implications are pretty large here. What you see there on my elbow is actually a flexible resistor. That basically just means that when you bend that strip, it changes resistance. So if you plug that into the Arduino can measure that change in resistance, and you can convert it into a signal that will control a servo. So you see I have a little arm there made out of popsicle sticks and servos, and it's supposed to represent, you know, a human arm. It's got a shoulder and an elbow and all that. It's very basic, but the point is that when I move my arm, I bend that flexible resistor, and then the Arduino takes that value and converts it into a servo movement. And so the servo arm mimics my arm, which is very cool. Because you can also apply this kind of technology to knees, hips, ankles. It's just, the applications for this are just enormous. And I don't know, this is one of my favorite ones to look at, and I would build it again. So there's a short rundown of some of the Arduino projects I've done in the past. Hopefully you enjoyed some of them and it's sparked your curiosity. If you have any questions, comments, leave them down below in the comments section. And if there's anything else you'd like to see, let me know.